In the previous videos, you saw how you can use Laravel short schedule and how it is implemented. In this video, we are going to take a look at how we test a package. When testing packages, I always highly prefer feature kind of tests. In these tests, I want to test the behavior and if everything is working correctly together. So I don't want to mock anything or use stuff in isolation. I actually want to run all the code and test the effects that it has. For testing this package, two problems need to be solved. First, I needed to find a way to add things to the console kernel programmatically. And secondly, I needed a way to stop the never-ending React loop. Before heading into the solutions of these two problems, let's take a look at the first test. And in this first test, we will make sure that the commands that we register will actually be called. First, we are going to register something to our short schedule. And we are going to use the exec method here. And the exec method is more or less the same as the command method, where you saw me using the test artisan command. But in the exec method, you can use bash commands instead of artisan commands, which is a little bit easier to use in our tests. In this bash command, we are going to append a string called in a temporary file. And we are going to execute that every 0.05 seconds. I've used low numbers here, so this test executes very fast. If I were to use whole seconds here, this test would also take seconds to complete. With that bash command scheduled to our kernel, I'm going to run the schedule for a given amount of time. And this should probably be slightly less than triple the amount of times that I gave it here. So in this time frame, this command should be called 2 times. I could also have put 11 here, but I like to have a little bit of margin. So let's actually run this test to see if it passes. And it does. Let's take a look at a few other ones. So it will overlap tasks by default. Here we are going to use a bash command as well to append a string to a temporary file. And after that, we are going to sleep for 0.2 seconds. So this command will take at least 0.2 seconds and a little bit more to write to that file. But that file writing time is probably very short. So if we run this command every 0.1 seconds, and we have a loop that runs for 0.59 seconds, then our temporary file should contain the string called 5 times. Let's run this test. And it passes. Let's review one more test together. It can prevent overlaps. Here we are going to do just the same thing as in the previous test, but we are going to add without overlapping. And with the command taking at least 0.2 seconds, then in a time frame of 0.59 seconds, our command can be only executed twice, so called should be written twice to the temp file. And of course, this test passes too. So I really like this method of testing. I'm not diving into any internals of the package. I'm not going to mock anything. I'm just trying to use it and make assertions on its behavior. To me, these tests give a lot of confidence that the package is working correctly. Now let's take a look at how these test methods actually work. So the first problem that we had to solve is that we should have a way to dynamically add things to a kernel. And in our tests, we use a test kernel. Before heading into the test kernel class itself, let's take a look at how we managed to register this test kernel as the actual kernel in the Laravel app. And it's actually very simple. Of course, we use the amazing Orchestra TestBench package. And TestBench has a handy method to specify which kernel should be used. So in our base test case, we just should add a method resolve application console kernel, and there we can bind the kernel to our test kernel. And now our Laravel application in our tests is using that test kernel. Let's take a look inside. Here you can see that the test kernel extends the regular kernel that is provided by TestBench, and on this kernel we added our short schedule method. We also added a register short schedule command, which takes on a closure. And we use that method in our tests. You can see it being used here. Test kernel register short schedule command, and we give it a closure. And that closure accepts our short schedule and it will register our command. Now inside the test kernel, we just keep that closure in an array, and when short schedule is called, we are going to loop over that array, and we are going to call each closure, and we will give that closure our short schedule so it can register that command. So this register short schedule command is basically a handy way of dynamically adding short scheduled commands to our kernel. So all of this solves our first problem. We can now just register things to our test kernel from anywhere. Let's turn our attention to the second problem that we had. Our package uses a never-ending loop to execute commands. So in our tests, we need to find a way to break this loop, otherwise our test would run forever and that wouldn't be very helpful. This problem is solved in the run short schedule for seconds method. Let's take a look. Here we are going to get a loop that stops after a given amount of seconds. And then we are going to give this prepared loop to our short scheduled class and call register commands and run on it, just like we do in our regular command. And in our regular command, we just use the regular loop. Let's head back to the test. So let's take a look at that prepared loop. Let's dive into this method. And it's actually very simple. First, we are going to create a regular loop. And then we are going to add a timer to the loop. And this timer should be executed once after the amount of seconds that we gave it. And in this closure, we are going to stop the loop. And this is all you need to do for having a loop that only runs for a specified amount of time. Let's head back. So with this loop in place, short schedule will only run for the amount of time that we give it. And of course, it will actually run those commands that we registered. And with the register command being run, things will be written to the temp file, and we can make some assertions on the contents of that temp file. And this assertion is very simple. Under the hood, we will use PHP's native substring count function to count how many times our needle is found in the contents of the temp file. And then we are going to assert if the actual count is equal to the count that we expected. So here you can see that it's actually very simple to add some custom assertions. And using custom assertions can greatly improve the readability of your test. Instead of getting the file contents and inspecting it here, you can simply use the custom assertion. If you want to know more about the package, then head over to the package on GitHub. I hope that you enjoyed this 3-part mini-series about this package, and I thank you for watching.